let's look at prime factorization. When we look at prime factorization, we need to review prime and composite numbers. So remember, a prime number is counting numbers that only have two factors of itself and one. The ones that have more than two factors, such as 6, whose factors are 1, 2, 3, and 6, are said to be composite numbers. So remember, a composite number is written as a product of all of its prime factors. Then we have prime factorization. So there's several different ways to utilize it for prime factorization, ways you can find it. All right, you could do it by using division. So if we're using 78, I can take and divide by a prime number that I know could go into 78, such as it's even, so I know I can divide it by 2. That gives me 39, and 39 its digital root is 12, well, 1 plus 2, so its digital root is 3, so now I can divide it by 3, and it gives me 13. So 2, 3, and 13 are all prime. So the prime factors are 2, 3, and 13 for 78. All right, so with prime factorization, and if you've noticed with finding greatest common factors, all of those things, finding those common factors as well, your divisibility rules have come in handy. So let's review those again. Okay, the last digit's even, then the number is divisible by 2. The last digit is 5 or 0, it's divisible by 5. The number ends in a 0, it's divisible by 10. And if the sum of the digits is divisible by 3, that digital root, then the number is also divisible by 3. So if that digital root is 3, 6, or 9, then the number is divisible by 3. If the number is divisible by both 2 and 3, then it's divisible by 6. And then if the sum of the digit is divisible by 9, so if that digital root is 9, the number is also divisible by 9. And just a little helpful one to kind of remember, just to kind of cuts things, I guess, in half, is that if it's an even number, it could be divisible by an even number. But if it's an odd number, it will not be divisible by an even number. So if we use a factor tree, so when you've got your number you're looking at, 78, and you break it apart into its factors. So whatever ones you could think of. This one's even, so I'm using my divisibility rule, so I'm going to divide by 2. So 78 divided by 2 is 39. 2 is prime, so I'm finished. 39 divided by 3 is another prime number, is 13, and they are both prime. So we got a prime factorization of 2 times 3 times 13, which equals 78. All right, let's try this one. How about 84? All right, so I'm going to do 2, it's even, so 2 times 42. 2 is prime, so I'm finished with that one. Now we'll break part 42. You can do 6 times 7, it's a fact we know, or I could do 2 again because it's even. I'm going to do 2 again, it's even, so 2 is finished. 21 is composite, so we still have to break that one down to its prime factors of 7 times 3, which they are both prime numbers. So the prime factorization for 84 is 2 times 2 times 3 times 7, which equals 84, or 2 squared times 3 times 7, which is 84. All right. So remember, factor trees may not always look the same because just your branches could be different, but it's going to give you the same final answer, the same prime factorization for no matter what you do. So if I did 72 and I did the composites of 8 and 9, because those are the facts that I know, which is fine, just got to, if it's composite, you got to keep breaking it down until they're primes. So I go, it's prime is 2 times 4, so 2 is finished. So circle it, highlight, do whatever to make you know you're done there. But it's important. You can't lose it. You got to make sure it's done, but you remember that it's still got to come all the way down to the prime factorization written out. So then 4, the factors of 4 are 2 and 2, which are both prime, so we're done. Go back up to 9 because it's the composite number and it's not finished yet. So the factors are 3 times 3, which is prime, so we're finished there. So 2 times 2 times 2 times 3 times 3. All right, same thing over here. If I were to do it because 72 is even, so I divided by 72 by 2, and I got 36. 2 is prime, so I'm finished. So now I take the composite number of 36, break it apart. 2 and 18. 2 is finished. Again, it's prime. Got composite number of 18, break it down. 2 times 9, I could have done 3 times 6. It doesn't matter. So 2 is prime, so I'm finished. Go over to the composite number of 9. The prime factors for 9 are 3 times 3, and those are prime, so we're finished. So if you see, your prime factorization for each of these is the same. There's 3 2's and 2 3's. So it's 2 times 2 times 2 times 3 times 3, or 2 cubed times 3 squared equals 72. So a method of finding the greatest common factor is to list the factors of each number, and the largest number is the greatest common factor. So here's all your factors of 72 and all your factors for 84. So you go through and find your common ones: 1, 2, 3, 4, 6, and 12. And then you find the one that's the largest, which would be 12. Or you could do it by using prime factorization. So you remember, you break it down the same. So you have prime factorization of 72 is 2 times 2 times 2 times 3 times 3, which is 72. Here's your factor tree for 84. For prime factorization is 2 times 2 times 3 times 7. So then you just take the common prime factors of each number and multiply to find the greatest common factors. So I've got 2 2's in each of them, so I'm going to put 2 2's over here. I've got a 3 and a 3, so I'm going to put a 3. I've got another 3, but there's not another 3. There's a 7 over here, but there's not a 7 over here. So the prime factors that they have in common are 2, 2, and 3. So I could do 2 times 2 is 4, 4 times 3 is 12. So another way of finding your greatest common factor, by finding common prime factors. All right, so your homework for this lesson, you need to write a summary about this lesson, write a question that you or someone else might have about this lesson, and bring in any work that you might have done while following along with this lesson. All right, see y'all tomorrow. Oh, just real quick, here are some good, helpful resources that are good if you guys want to go check it out, get some a little more practice done. The Brain Pops on prime factors, prime numbers, and then Math Playground factor trees, which we are going to be looking at a little bit later on this week. All right. See y'all tomorrow.